Hi everyone, my name is Eric with BobCAD-CAM. I am the demo technician with BobCAD-CAM, and I wear a few hats here. I am part of technical support, so I do support calls. Again, if you call us or email us, you're put into a ticket system and we log in and help you guys out with any questions you have in the software program. And I also do some of the training with BobCAD as well. I'm one of the trainers here. So you could pay for a certain number of hours that you want with training, and you could book a 1-hour session or a 2-hour session with one of our trainers here to do one of the part files that we're looking at today here, or any part file that you have, and work on that. I also do tech support. Oh, and also demonstrations of the software program. So for any potential customers, I do a demonstration of the software program to let them know what the software program is all about before deciding to purchase or upgrade to any of the programming needs that they have. So we'll get started here. Again, we're going to be looking at the Mill 3-axis Premium toolpaths today. And I've got a pretty basic part, as you can see, with this square block, but inside of the pocket here, we've got some of these tapered walls that we might want to do some of the premium toolpaths on, and I can show you the benefits with that versus our Mill 3-axis Pro package. And again, if you guys have any questions, comments, anything like that, let me know in the comment section. More than happy to answer any questions you guys may have with the 3-axis Premium and anything else inside of the software program. I can help you or direct you where you need to go there. So we'll get started here. Basically what I did to begin with my 3D model, I did a couple, we can see how I created the model here. By going to the CAD tree, I created an extrude boss of most of it here. Then on the inside, I think the easiest way for me to do it, if I hide the solid layer here, or the layer that the solid is on, I created some wireframe here, created the wireframe on top for this tapering going down in, and then I did a ruled surface. That was pretty interesting. Under Create 3D, the ruled surface, I can just select the top profile and the bottom profile to create that tapering there. And then the rest of it, I just did an extrude boss from the bottom going down, and I did an extrude boss from here going down as well. And it just added everything together there with the extrude boss automatically. Now you can see some of the reverse surface normals. This we can get into as well when we're getting into the 3-axis Premium. I can explain that a little bit better. That can be really useful for the 3-axis Premium toolpaths. It's a little bit technical for us to get started right off the bat, so I'll leave that for the 3-axis Premium toolpaths. So to begin the milling job, we go to the top and go to CAM, go to a new job, and we'll be doing a milling job type here. And we can select a certain machine here. If I have a different milling machine, I say, for example, a Haas, I can select the Haas 3-axis mill here, and it will be formatted for a Haas milling machine. I'm going to go back to the default one, which would be the BC3X mill, and that's going to stand for BC stands for BobCAD in here, BobCAD 3-axis mill, and that is a Fanuc-based toolpath for us when we select that. And we'll go in, we go to the stock wizard next. We can define our workpiece. So if I have a finished 3D model like this here, I can just click on it. That would be my selected geometry for my workpiece so that I can see that in simulation. And then I go to the next page. We can define our stock, whether it's a rectangular piece of stock like I have here, if it's a cylindrical piece of stock, or I can extrude it from wireframe, select an existing solid model or STL model here, or even create a revolved surface for my 3D model if I want. I'm just going to go back to rectangle and click calculate stock and go to our next page here. And here's where I can define my machine setup. You can see if I hide the solid surfaces there, our machine setup starts at the CAD origin location. Now, if I'm touching off my tools at one of these corners at the top of the part here, or anywhere else, I can highlight this origin box over on the left-hand side, and then I can click on maybe this corner is where I'm going to jog my tools over to touch off on that corner for my G54 work offset. Then I'll scroll down and click OK, and that's where everything's going to be lined up, everything here in the CAM tree, all of the information for my stock, my machine setup, all that kind of good stuff there. So I'm going to highlight the milling job I just created. I'm going to hit delete on my keyboard to delete that one out. And I've got the milling job that I'm working with again, my stock, my machine setup here. Everything's blanked out at the moment because I clicked on this icon over to the left-hand side to show or hide the stock, the toolpath, and everything like that. If I want to show or hide a specific feature, I can just go down to the feature here and show or hide the toolpath for that feature there. So to start our milling operations, we right-click on Machine Setup 1 down here in the CAM tree, and we go to all of our milling operations. You can see here, I'm going to break down the three basic toolpath tiers that we have, our three basic milling tiers. So our first one is going to be Mill Express, and that's considered 2.5 axis milling or 2.5 axis machining. And what that will unlock under Mill Express will be the mill drill hole, mill tap hole, counterbore operations. Then we get down to mill 2 axis here. So Mill Express will unlock all of these available operations: the profile rough, the profile finish, pocket, facing, engraving, chamfer mill, corner rounding, all the basic milling operations there, where the tool is going to come down in Z, move around in X and Y, and then come back up in Z, so that it's not going to move in 3 axes simultaneously, it's just going to move in 2 at the same X and Y at the same time, and then move back up in Z. Then we'll get into the Mill 3-axis Pro, which is what I started with here with the roughing operation inside of this pocket, by right-clicking on Machine Setup 1 and going to Mill 3-axis. Now I describe it as 3 different tiers. You know, we could get a little more technical with the standard versus the pro. The standard, the 3-axis Mill Standard and the 3-axis Mill Pro are included right here under the Mill 3-axis Wizard. So under the machining strategy, if you want to follow along, open up BobCAD and you can go to Mill 3-axis here under your machine setup, under an existing milling job. And you can see the available operations under Mill 3-axis. The Mill 3-axis Standard will unlock the Z-level rough, the Z-level finish, the planar toolpath going back and forth across the surfaces, spiral, radial will start at the center of the stock and move outward and go around this way here, a certain degree pattern there. 3-axis plunge rough, where the tool, you'd be using an end mill to sort of plunge down into the stock to rough it out. So those 1, 2, 3, 4, 5, 6, 7 operations. Oh, sorry, 1, 2, 3, 4, 5, 6. Can't count today. These 6 operations at the top here under our available operations for the 3-axis Standard is what's included. And then below that is the 3-axis Pro that we're getting into. And you can see basically all of this is packaged together because you've got your Z-level rough and you've got your advanced rough. Those are basically the same things, but the advanced rough is going to have a lot more options to optimize your toolpath. You've got your Z-level rough up at the top here. Down at the bottom, we have our advanced Z-level finish. We have our planar toolpath up at the top. Down below in the 3-axis Pro toolpaths, we have our advanced planar, and so on and so forth. We've got some other finish operations here under Mill 3-axis Pro we can look at. Flatlands will detect all of the flat areas of a 3D model and mill those out with a flat end mill. Equidistant, sort of a spiral toolpath that'll go on the outside boundary that we select and offset to the center, giving us a better surface finish. Pencil will mill all of the fillets along the edges of a part. Planer again, just going back and forth as a finish pass. Project curves, where we can project a 2D shape onto a 3D surface to do a 3D engraving operation. We also have a steep shallow option, which is basically combined the Z-level finish and the equidistant toolpaths there. So what we're doing here that we're looking at in my first feature, I'm doing a couple advanced roughs, and then I'm going to be doing a planar toolpath. And we're going to sort of breeze through this pretty quickly because we're going to be getting into the 3-axis premium right after this, which is what we're going to be focusing on today. But most of this is going to be just roughing out with the 3-axis Pro. I start with an advanced rough toolpath. If I wanted to add more operations into my feature here, so a feature here in BobCAD, if you look over here on the left-hand side in my CAM tree, we've got feature 3-axis, which is basically just a group of operations, my 2 roughings and my planar toolpath here, and then another group of operations, which we're going to be looking at deburring next. That's in the 3-axis premium. So we start with the advanced rough, and if I want to add another operation in this group of operations or this feature, I can go over here to the right to available operations, say I want to add an advanced Z-level finish toolpath. I can add that in with this arrow here in the center. And you can see it add right here below what was highlighted under current operations. And I can sort the operations with these up and down arrows down towards the bottom here. And if I don't want any of these operations, I can delete them here as well. So we go to our next page. We have our work offset number. So number 1 is G54, number 2 is G55, 56, and so on. And we get down to the next page with the tool. I can set up the diameter of the tool, corner radius. If I scroll down more towards the bottom here, we have our feeds and speeds, which are our spindle RPM, our cutting feed rate, our plunge feed rate, all of those settings. Sort of as a side note, I can manually change the numbers here for my spindle RPM and my cutting feed rate if there is a specific well, I can set them manually here if there's a specific number I want to set, or I can check the box use system feeds and speeds, and that will calculate all of my spindle RPMs, cutting feed rates, all of those settings based on the material that I'm using for my stock here. Now the material type is found in the CAM tree, and it's down here just above the machine setup 1, just above it where it says stock. I would expand that option by clicking on the arrow next to it. And you can see down below that we have carbon steel, is what it says. If I double click on that, it'll open up my material library. So whether I'm machining from carbon steel, aluminum, different types of plastic, I have feeds and speeds for each material type. I can double click on material type like cast aluminum here. And you can see the general feeds and speeds up at the top based on the material type of cast aluminum. Over here to the left based on the tool type, whether it's carbide, an insert tool, or high-speed steel, we have speeds and feeds for each tool type as well. You can see up at the top, SFM is surface feet per minute, SFM for tapping, chip load per flute, so we've got all of those numbers set up automatically. You can always double click on a material type like that and change the numbers here. You can also go to, like if you don't see a material type that you're normally using, for example, wood. We don't have a material type for that just because there's so many variables for that. So we go to add group over here. We can name the group wood. And it'll add that group over here in the material group on the left-hand side. I can go here and add a material, name it, and set my surface feet per minute and all of those settings. Now you can see here under aluminum, for example, there are numbers in here by default for your feeds and speeds. But we always recommend our customers contact their tooling manufacturer to make sure that these numbers are dialed in for your specific tooling. We don't want to break any tools or anything like that. And then we get to the next page after our tool page here in this feature. We have some different cut patterns. So parallel here, we'll just zigzag back and forth across the inside of the pocket that I selected. Offset out will start from the center and step over each time and work its way out to the walls of the pocket there. Offset in will start from the walls of the pocket towards the center. More spiral will start at the center and continually spiral its way around there. And adaptive roughing, which is again sort of another spiral toolpath. These are our high-speed machining options, the morph spiral and the adaptive roughing. If you see in these offset operations, you're wasting time stepping over every time when you get to the next pass. In the morph spiral and the adaptive roughing, it's going to start at a certain location, continually spiral its way around, keeping constant tool engagement the whole time. These are found in the Mill 3-Axis Pro. And the adaptive roughing, if we're doing one directional cutting, this is where we have our tricoidal milling. If you're familiar with that term in other CAM software programs, you'd be familiar with adaptive machining or dynamic machining or dynamic roughing. Those terms are the same as what we have here in adaptive roughing. So the tricoidal milling, you can see the linking moves here in yellow. The tool is going to machine and go while it's machining across one pass to get to the next pass on the other side here. It's going to retract just a fraction of an amount and wrap it across to give you your tricoidal milling there. Then we've got our next page. Our depth of cut we've set to 400 thou. Our step over we've set at 1/8 of an inch right here. We're leaving a certain amount of material for the finished pass to clean up, 15 thou. That's why I've got the second advanced rough. It's just going to clean up that extra 15 thou for us. Then we can plunge, we can ramp in or spiral into the material entering into the stock. Options, we'll get into rest roughing in the next advanced rough here, but this machine flatlands can be really useful here. We'll take a look at that here. With that checkbox machine flatlands, if I look at it from a side view here, I'm looking at the wireframe of the solid model. Here's the first floor that I'm getting down to, and here's the second floor that I'm getting down to. This depth right here from the top of the stock down to this first floor is 3 inches. So when I'm going down each depth of cut of 400 thou, you can see here it's at 400, 800, 1, and 200. And when it gets down, it's only going to get to, this is 2.8 right here, basically. So it would have just kept going down to this location here for the next depth of cut of 400. But since I turned on machine flatlands, it's going to detect, hey, there's an extra 200 thou at the next location to be machined. All of those flats there, machine those as well. So sort of gives us an adaptive depth of cut there to make sure everything is cut to size with that machine flatlands option. Neat feature to use. I use that pretty normally. I use a couple other options pretty normally here in the 3-Axis Pro that we can get down to. Linking for each step over, a gouge check page to make sure that there's no gouging with the solid model, with the workpiece, or anything else within our fixture there. Advanced feed rates. I can convert rapid moves to feed moves, linking feed rates. Adaptive feed rates is another good one here in the 3-Axis Pro. With adaptive feed rates, I can set a minimum and a maximum feed rate. When the tool is getting into larger material at a time, like into these corners, the software can calculate how slow the tool needs to move to keep a constant chip load, and that can reduce chattering at the machine. Then our last page here for the first adaptive roughing is MDI, which stands for manual data input. If I wanted to add any GRM codes in here or any comments or anything before or after an operation, I can add that into this page here. Next, we get to the next advanced roughing, I started with a 3/4 inch tool. Now I'm using a 1/2 inch flat end mill. My next page, I'm just using an offset out toolpath there, setting my depth of cut, going down the full depth of the first floor here of 3 inches, because I'm just doing one pass around the full profile of the pocket there. Step over, not super necessary, maybe just down to the flatlands, because again, in my first advanced rough, I'm leaving 15th thou on the floors as well for the finish pass to clean up, so I am doing an extra 15th thou on the flats there. You can see I am machining the flatlands again here. And now we'll get into the rest machining under options. So rest roughing is where I can tell the software the previous tool diameter and the previous corner radius of the tool that I used prior. And the software will calculate any areas the previous tool couldn't fit into and calculate just that toolpath for us. So essentially, it's going to start right where we left off from the previous operation and avoid any error cutting. So a lot of good stuff in the 3-axis Pro that we're looking at first to get to our 3-axis Premium. We've got into linking for each step over for the next advanced rough, gouge check, advanced feed rates, and MDI page. Now we're getting into the planar toolpath. Actually, let's see the first advanced rough here, doing a lot of roughing there, stepping over 1/8 of an inch and then dropping down 400 thou each time. Next, we've got our advanced rough. If I highlight one of these operations over here in the CAM tree, I can just highlight that one if everything else is blanked out. So here's our next advanced rough. Again, it's just going to go along the profile and it's going to machine the flatlands down to size there. So instead of having to do a 2-axis profile pass, doing a couple of 2-axis pocketing operations, I don't have to do that here. Just do it all in the 3-axis Pro. Next, we've got planar. So I'm just going to focus on one of these tapered walls. I actually got into this very similar type of part file with a customer. I created this on my own. But, we ran into tapered walls like along here, and he had the 3-axis Pro, and I showed him the benefits of the 3-axis Premium to help out with that. Because first we start with a planar toolpath, and if I look at, I contained the toolpath inside of this area by creating a boundary just for that specific operation in the feature. So let's look over here in the CAM tree, under the first feature here. I selected my geometry, but I did not select a boundary. Now that boundary is going to be used for the advanced rough, the second advanced rough, and the advanced planar, unless I drop down one of these operations. So I expand the advanced planar here on the left of it, and you can see all of these options here. Boundary is where I can contain the toolpath for just this one advanced planar operation. It'll override the first boundary for the whole feature of all of the operations. So there's our boundary for just the planar toolpath, just the edges of this tapered wall surface. Next, we've got operation stock. So if there was a solid that we wanted to tell the software of what we're machining from, that's what operation stock is here for. And then rest finishing stock, same kind of thing. And then our gouge check surfaces we can select as well. So I selected a boundary here for the planar toolpath. We're just going to be focusing on this one for the moment to see the differences between the 3-axis Pro and getting into 3-axis Premium finally here. So the planar toolpath, I'm going to take a look at how it looks here by right-clicking on the operation, right-clicking on advanced planar here in the CAM tree, and going to backplot. It's going to be 5th one down. So under backplot, I'm going to either step through with this next button, clicking on it each time, or I can just play through it here and change the speed of it here. So this is going up and down along the y-axis specifically. I can go back into the planar toolpath and change the lace angle right here 90 degrees. This is the page right after the tool page of the planar toolpath. The next page is my lace angle direction. The angle direction of 90 degrees will go up and down along the y-axis if I set it to 0. And compute just the planar toolpath here. You can see it's going back and forth along the x-axis. And I can do anything between 0 and 360 there. If I set it to 45, for example, it'll do a 45-degree angle cut along the surface. That might look halfway decent. It's just because it's got a sort of a tapered surface on a 45-degree angle. Maybe I could even do like 135, or I could even do negative 45 if I wanted to, I suppose, in here. It's okay with negative numbers. But you can see it's not following along the contour shape here. Just going back and forth at a 45-degree angle. And we can look at it in our simulation too to see how that's going to play out, machining the surfaces there. So here we've got the 3-axis Pro toolpaths that we looked at first. The advanced rough, going down a pretty large depth of cut at each time there with the 3/4 inch tool. Then a second advanced rough, just machining the rest of it with our rest machining with the 1/2 inch tool. And then the planar toolpath. So here's the 1/2 inch tool. And then once I get down to the last pass there, we've got our, now the red showing is that the tool, the flute length wasn't long enough, and the non-cutting part of the tool is hitting right there. That's what that red's for. So I'll zoom in and we'll look at the planar toolpath. Once I hit run, we've got a 1/4 inch ball end mill, and it's following along now. It's going at a 45-degree angle. It's not exactly following along the contours of the surface there. So to give us a better toolpath than we've got here, we can close out of it, and we've got our premium toolpaths. So that is found once it's unlocked in your software program. You can right-click under Machine Setup 1, and it's found under Mill Multi-Axis. It's right under Mill 2-axis, 3-axis, 4-axis rotary, and then Mill Multi-Axis. So I select that, and we have, just to sort of give you a brief history of the Mill 3-axis Premium, back when I was working, when we had V30 and V29, it was unlocked only if you unlock the 4-axis toolpath in BobCAD. Now you don't have to purchase 4-axis if you don't have it. You can purchase the 3-axis premium toolpaths. That's why it's sort of situated in here with the wireframe toolpath up at the top. That is going to be for 4 and 5-axis machining to tilt the tool at a certain wireframe location. Multi-axis machining for 4 and 5-axis roughing. Swarf machining for 5-axis following along tapered walls. Multi-blade, this is going to be 5-axis for machining impellers. Port machining, these two are in 5-axis premium, where we can do porting for engine blocks and things like that. We'll be getting into deburring next. That's offered in 3-axis. Turn milling is 4-axis. You're basically turning down and roughing out a cylindrical part, sort of like turning down the stock, but with a milling tool. And then surface-based toolpaths. All of these are unlocked, as well as the deburring in the 3-axis premium. So we're going to be, sort of, what I can do is give a brief description of all of these operations, and then we'll be looking at a little closer look on some of these operations as well. So parallel cuts we'll be looking at a little bit later. Parallel cuts is where the tool can work down the surface like this here, or work across any surfaces, just setting your specific step over. Cuts along curve, you can see we're selecting surfaces that we're finishing. These are all finish operations. So this second option, cuts along curve, is where I can select surfaces, and the toolpath will go perpendicular to any wireframe that I select, like this orange wireframe highlighted. You can see the toolpath is just going to cross past the wireframe I select as my lead curve. Next, we have morph between two curves. That's the one we're going to be looking at next, is where I'm selecting one edge of the surfaces, selecting all the surfaces I'm finishing, and then selecting a second edge of the surfaces, and it will morph the toolpath from the first edge along the surfaces to the last edge. So any kind of complex shapes like this hourglass shape up at the top, it's going to start at the top here and work its way down to the bottom past there. Next is parallel to multiple curves. We can select some wireframe or surface edges like this here in orange. The toolpath will follow along those surface edges and create an array of the toolpath outward. You can set how many steps over you want to do there. Project curves is just like in the 3-axis Pro project curves in this one. We're just going to project the geometry onto a 3D surface and do a 3D engraving. It's only in here for multi-axis, mainly for 4 and 5-axis engraving as well. Morph between two surfaces. So if you're going down into a channel, you can select the sidewalls here, and the software, just like the morph between two curves, will morph the toolpath from one surface to another, and also make sure there's no gouging in deep into this channel here. Parallel to surface, similar to parallel to curves, you're selecting surfaces, and it will create the toolpath around the surfaces there, and create an array of the toolpath outward. And flow line. The morph between two curves that we're going to be looking at and flow line, they both support undercutting. So I'm selecting this curved surface right here, for example. We can use a lollipop tool, and the lollipop tool can work its way up the surface and do an undercut with this. So a lot of great stuff here. I'm going to go to morph between two curves, third one down, and I'll show you the geometry selection of what I'll be doing to focus on that one surface we're focusing on first. Our next page, we set our work offset number for G54 there. We set up our tool. I'm using a 1/4-inch ball end mill just to start off with. Pretty large tool to get down into there, but we can always change that later. Then we have our geometry selections. That's up at the top here. Under Edit Curves, the first two buttons here. So the first edge that I'm selecting will be where the toolpath is going to start. So I'm going to select this top surface edge. Then the second edge curve is going to be the bottom edge that I'm selecting. That's where the toolpath is going to end. And then the drive surfaces. It's just going to be this one surface to start with. We can go all the way around after this, but just to focus on one surface first. The difference between the planar and the morph between two curves here. Now below that, we have drive surface offset. This is the offset just like the allowance in the 3-axis Pro. You can leave a certain amount of material for the finish pass to clean up, or we can penetrate the walls a little bit further past with a negative number there. Then below that, we have some different options of how we want to machine the surface. So full, avoid cuts at exact edges. So we're just offsetting a little bit from the edge of the surface starting and ending right before the edge of the last surface there. Next one is full, start and end at exact surface edges. So we're starting our toolpath where the tool is going to start right along the surface edge at the top and the surface edge at the bottom. Next is determined by number of cuts, and I can set exactly how many number of cuts I want to do. And our last one is limit cuts by 1 or 2 points. So I can actually create geometry and tell the software exactly where I want to start and stop with any points I create in the CAD geometry there. It's normally set to full, avoid cuts at exact edges. That can be a good one here because I'm not going to try to penetrate the floor of the solid model there of that pocket. Below that, we have some checkboxes. 2D containment is where I can set a boundary. Round corners is where I can just go into the corners like this here, or if it's unchecked, it does sort of like an extra little move there to get into the corners deeper if possible. Below that, I tend to use this one a lot, trim and extend. So if I click on this button here, we can set a tangential extension. So we'll see this a little bit more in the next part file, the other part file that I've got to work on. But if I set a positive number, it'll start a little bit before the toolpath to work its way in. Sort of a lead in and a lead out, but you're extending the toolpath more than just a lead in and lead out. You're still machining at that level. And also at the end of the toolpath, for each step over, you can go a little bit further past. Based on the percentage of the tool diameter, so if I set it to 50% here, it'll go an extra 1/8 of an inch. Or if I set it to a certain value, I could start at 1/2 an inch before each step over, working its way in there. Now, down below that, we also have side extensions. So it'll start a couple of step overs before the surfaces and end a couple passes past the surfaces if I select the side extensions there. That's what that's for. Angle range, I don't use that a whole lot because that's mostly to do with 4 and 5 axis, but if I wanted to limit, like if I'm cutting a sphere like this, I can limit an angle from where I'm starting and where I'm ending the toolpath there. Next, we can set one directional cutting, and I'm going to leave all of these numbers by default so that I can show you other settings to manipulate the toolpath and optimize it a little bit better. So one directional cutting, we have zigzag cut or spiral toolpath as well. And we can climb or conventional mill here. We can set a step over amount here. And actually, this is where I can stop and show you the step over amount. This is probably the best thing that I can highlight in the 3-axis premium. Right now, we're setting a step over of 50 thou. But if what I would have to do to make sure everything is cut to size is set a certain step over to start with, go into simulation and make sure everything is cut to size. If it's not to my liking, if it's not cut to size, not the right tolerance levels, I'd have to go back in and have some kind of guess and check work there to change the step over again, make it smaller, make sure it's cut to size, keep going back and forth in and out of simulation. That would be in the 3-axis Pro. In the 3-axis Premium here, the option below it here is cusp height. It's probably the best option here in the 3-axis Premium, where I can highlight that number, and you can look at the example. This is where I'm setting my cusp height or scallop height, some customers will call it, or the tallest peaks of this surface that I'm machining to get down to size. Well, I could also call it a tolerance level, I guess. So with the cusp height, if I set it to 1 thou, so just type in 1 thou, you'll see that the maximum step over number will automatically update. And it automatically updates to 31 thou for the maximum step over. So based on the cusp height of 1 thou, this is the step over that I need to achieve that. So it calculates it for me. I don't have to go into simulation, make sure everything is cut to size and the tolerance levels are 1 thou exactly. I can just type it in here and BobCAD will give me the exact step over that I need. Don't have to do any guesswork involved with that anymore in the 3-axis Premium. So then it's a little different than the 3-axis Pro also in terms of workflow. You'd be used to just keep clicking the next page here to go to all of the other pages, but the only other page here is MDI for manual data input. If I go previously, Up at the top, we have our different tabs. That's sort of how this is sorted in the 3-axis Premium. So our first page here was surface paths that we worked through. Tool axis control is if this is 3, 4, or 5-axis machining. It's only going to be 3-axis here unlocked if you have it unlocked in a 3-axis Premium. 4 and 5-axis would be unlocked if you paid for it there. Next will be the gouge check page, just like in the 3-axis Pro. Next, we have linking for each step over. We'll look at that after I compute the toolpath. Roughing, we can set, like for example, I usually go here to depth cuts. So if I wanted to do multiple passes, set a depth of cut here, number of roughing passes and how far they're going to be spaced out, and a number of finish passes and how far they're going to be spaced out. And I'm going to turn that off. And then our last page here is utility. This is just some miscellaneous G&M codes I can add in here, a certain feed rate percentage for my first cut, constant width for each contour, things like that. I tend to not change anything in here really. Most of the stuff is just going to be right here on the first page to change tolerance levels, change cusp height, and step over is the best one there. I do the trim and extend option a lot, and I'll hit compute down here at the bottom. Well, that's computing. If you guys want to let me know, if you guys have any questions, please let me know in the comment section, and more than happy to answer anything at the next good stopping point there. So here's our toolpath for the morph between two curves to start off with. I'm going to optimize it a little bit better once we look at it a little more. So first of all, we're doing one directional cutting. And if I backplot the morph between two curves, it's going to start here. I'm going to have to make the tool a lot taller there. We've got a collision right there. So let's start with that. I go to the tool page. I modify the tool. And I make the protrusion length at least 4 inches deep into that pocket there. And hit OK. And we'll backplot again. And we'll zoom in. We'll see that once I step through, it does one pass here. And now it retracts up to the clearance plane every single time with my one directional cutting. I don't want it to retract every time like that. So to change that, I can close out of the backplot. I can go back into the feature here under that parameters page. I'm going to change it from one way to zigzag. But we've still got some link moves here. I don't want it to link back up between groups of the toolpath and things like that. I want it to make sure that it's not going to do that there. So to change that as well, I can go in, and even if I wanted to do one directional cutting, I can change those linking moves by going to link. And under these direct options here, you can see we have direct moves for small gaps, and for large gaps, I can change these options here to direct moves rather than retracting to a clearance plane. Then you'll see that it's just going to start up at the top, work its way down, and then once it's done, it'll work its way back up there. Let me see, it looks like it's penetrating those walls there. So the only thing I would also need to change is going into my gouge check page and make sure that it's not going to gouge into those walls. And check the surfaces along the other sidewalls there. I tend to select the 3D model so that it doesn't do any other gouging as well. You can see how it trims the toolpath back just a little bit there. So we can take a look at how the planar looks. Yeah, let's take a look at that actually. So let's see the toolpath highlighted for the planar first. This is in the 3-axis Pro. And you can see it's just going at a 45-degree angle. I'm looking at it from a top view now. and looking at the planar toolpath, okay, yeah, it's going at a 45-degree angle, but it's not actually following the contour. You can see all the small step overs it's got to do in this area here, all the small step overs to do here in this area, and it's not following the contour, so you're not going to get the best surface finish for this either. If I highlight the morph between two curves, you can see it's actually following the contour exactly along there. And you might be thinking, oh, why is it starting so far down there? What it's doing in the 3-axis premium toolpaths is it's starting right here down at the bottom. Now the toolpath is showing where the tip of the tool is going to be positioned. But what the 3-axis premium toolpath does is it offsets for that toolpath right there, so that the best contact point of the tool will start at the edge right here. So instead of wasting your time, not only in the planar with not only wasting your time with the extra step overs there and the extra passes, instead of using the tip bottom of the tool to machine all of the finishing there, you can go into the morph between two curves, and again, it starts right where it needs to start there for just the edge of the radius of the tool right there to start on the edge there and save time that way and giving you a better surface finish as well. So a lot of great stuff there in the 3-axis premium to manipulate your toolpath and optimize it the best way possible. Once we get to the end of the progress of the toolpath here, let's see the last pass. And you can see all of the solid green lines here in the toolpath. Those are all machining moves there, feed moves, and the pink moves there are linking moves, feed moves as well to get down to the next step over there. And it gets down to that floor there and machines as much as it can and then retracts back up. Yeah, so a lot of great stuff with the 3-axis premium to start off with. If you guys had any questions with that first premium toolpath of morph between two curves, please let me know. More than happy to answer any questions there. I'm going to turn off the planar toolpath by hitting this post yes no option over on the left hand side. You can see it's right next to the blank toolpath. Blank or show toolpath with the icon of controller with the red X. What it's doing is it will not simulate the planar toolpath in my simulation, and it also won't post the G code if any of the operations here are turned off with that post no option. So I've got that turned off, and I'm going to change the geometry selection type for my morph between two curves, so it's going to follow all the way around the tapered walls there. And to do that, I just double click on the feature again to edit that. Go down to the surface paths page here, selecting my geometry. Instead of my first edge curves of just this one here, I'm going to deselect it by clicking on it. Now I can individually click on each one of these surface edges. I think the easiest way for me to do it, at least, what I like to do is just right click on one of these surface edges. We have a constant Z option. So all of the other surface edges connecting it in a constant Z location is going to be chain selected. Or if I right click on the surface edge again here, we also have a loop selection. Now it'll highlight different loops for me. And if I zoom in, all of the constant Z edges here are one loop. If I zoom in a little bit further, you can see these are highlighted as well. So it's asking me which loop do I want, the one in constant Z, or this loop where it's the top one here, the side one here, the bottom of this surface, and the side one of this surface specifically. I don't want to select just the surfaces, just the edges of this surface. I want to select all the edges on top here. So I just have to click on one of these other edges to chain select with that loop selection as well. Sometimes loop selection doesn't always work out for me the best because sometimes it doesn't pick up everything into constant Z. So I usually just go with constant Z there, as long as all of the edges are on a constant Z level there. Then I click OK. I do the second edge curves, which are going to be down at the bottom. And I'm going to deselect what I had before, and then right click on one of the surface edges down at the bottom and constant Z and click OK. Let's see, drive surfaces. I have this one selected. I just need to select the other surfaces around and click OK. And we've got our cusp height of 1 thou, which gives us a 31 thou step over rate. Zigzag back and forth, or maybe I could spiral if I wanted to with this one. Might look pretty good, just continually spiraling down. I'm going to turn off the gouge check because I think we're good with that. We'll hit compute, and we've got our toolpath here. Nice and uniform, just going around, even going around the corners. Oh, we might actually have to do a gouge check, don't we? I don't know if it's penetrating that corner there or not, but we'll just going to be safe than sorry, so I'll just select the solid model as a gouge check. Oh yeah, that looks a lot better. Cool. Next, let's see if I can work something out also here. Let's do that front layer. We'll get into the surface normals as well before we get into anything more here. Not giving me. I'm trying to make something go wrong, but it's not working out for me. Just to show you if there was any kind of error with the toolpath here, it could be due to dried surfaces and surface normals. No, it's not working out for me. Oh, at least I will explain it to you as well, just in case you run into this issue. I'm not able to reproduce it, which is a good thing, but just not able to give you an example at the moment. So what I'm doing here, as you see in the CAD tree, we have all of these functions called reverse surface normal. Now, surface normals can be found if you go to the top, go to utilities, and you go to reverse surface normal. It's all the way to the right-hand side here. If I click on that, you can see all of these red dots on the surfaces and these red tails going outward of the surfaces there. So what that's doing basically is it's telling you what's the outside of the surface. Now if I click on this surface here to reverse the surface normal and click OK, the tail will be pointed inward. You can see it through the solid model right here where my cursor is. So if you are getting any toolpath like this here that could be penetrating past the tapered walls here that I selected, it could be due to the surface normals because BobCAD is recognizing, BobCAD may be recognizing the surface normal for one, for example, like this, as the surface to be machined on the other side of the surface, basically. Your compensation is wrong. Best way to describe it. So to change that compensation, you can change the surface normal. Tell BobCAD the outside of the surface is actually the opposite of this. The tail is pointed away from the outside of the surface. So we want this to be reversed, just like the one on the left-hand side looks like to the left of it. So again, I go to Utilities, go to Reverse Surface Normal, click on the surface with the tail pointed inward. I would click OK, and now the tail of the surface normal is pointed outward from that point of the surface, outward of the surface there. If you guys have any questions with surface normals, please let me know. You can see or hide the surface normals, just look at them very quickly by hitting N as in November on your keyboard to show or hide the surface normals at any time, just to get a quick look at it instead of having to go into utilities and reverse surface normals there and having to cancel out every time. Then, now that we've got the surface normals out of the way, we can take a look at the toolpath here. It's looking great, starting from the top edge there with the tool radius and working all the way down the tapered walls there. We can backplot it, and maybe we could also simulate what we've got, but this is looking really good. We can also take a look at, maybe just look at the wireframe of it here. There's a shortcut key for that as well to hide the surfaces of the solid model by hitting S on my keyboard. S is in solid. Oh, now it's doing, maybe the zigzag isn't what I necessarily want here because it's going one direction and going back and forth along there. That's what's great about the backplot. You can see if there's anything that you don't really like. So we go back into morph between two curves and we go into one direction, cutting, and now it will go down and follow along the whole time, either climb mill or conventional milling the whole time there. Cool stuff. So yeah, let me know if you guys have any questions with the morph between two curves. We'll be getting into the deburring next. And we'll take a look at some of the other surface-based toolpaths after looking at deburring here in the 3-axis premium. Just let me know if you have any questions with that. Shoulder sort of cramping up. Take a quick break here and grab some coffee too. But yeah, let me know if you guys have any questions with the 3-axis premium so far, what we looked over, all the different parameters we've looked at, a lot of stuff that we've seen in the 3-axis premium that we've gone over. The cusp height is probably the best one that I like, showing customers that might be getting a little bit more involved with the premium toolpaths there. All right, so getting out of backplot, we'll go to our deburring operation that we have in this feature that I created. And again, that's found under the CAM tree, right-clicking on Machine Setup 1 and going to Mill Multi-Axis. It's found third one from the bottom here, deburring, under the main categories of toolpaths. And you can see here we're using, in this example right here that we're looking at, this is with the lollipop tool. We could use a lollipop tool, any sort of spherical tool, or any sort of form tool. You could even use a chamfer tool to do a deburring operation to break any edges along the corners of a 3D model that you have. Go to the next page here. You set your work offset number. You have your tool page here. I'm just using the same 1/4-inch ball end mill here, leaving the feed rates alone here. Our next page, parameters. So first we go to part surfaces, and basically I just click on this button to the right of it, and I usually just select the solid model. So what that will do, as I hit compute, it's just going to calculate all of the toolpath all the way around the solid model. Actually, go back to it here. It's actually going around down to the bottom and the sidewalls because right now we are in 5-axis, so we have to change that as well. That's found under the deburring feature after the tool page. It's the next tab over tool axis control. I want to make sure that this is set to 3-axis. And then after that, we've got some clearance settings. If we want to add an extra clearance amount for the holder, the arbor, the shaft. We have linking options if we wanted to set a clearance plane for link moves. But back to the surface paths page here, the first page. We're selecting our part surfaces first. We're selecting the solid model. And when I click compute, it will do all of the deburring along all of the edges with any sharp corners. So let's say if I wanted to focus on just doing the inside edges rather than the outside edges at the top of the deburring here, I go back to the feature, go to parameters, and it'll be under edge detection here, this third option down. I can exclude certain curves or I can include specific curves that I want to be machined. So let's say that one, and I just want to select the inside edges here to be machined rather than the inside and the outside. So I just select those curves to be included, and everything else there won't be any toolpath for on the solid model except for what I select. Kind of a similar option here with exclude curves. I can just exclude any edges that I don't want to be machined there. Then the next option down, we have a constant width or a constant depth into the corner there. And we have our amount there, the constant depth into the corner at a 45-degree angle, or the constant width across the chamfer that we're creating, basically. Then we have our inner corners, trim or relief, kind of the same thing as with the premium toolpath before of getting into the corners a little bit better. Let's see, direction, climb mill or conventional milling. Number of cuts along edges, so if we wanted to set a step over amount, we can do multiple passes. We can overlap a little bit further past there, extend the toolpath past what we've cut, and set a tolerance level there. And yeah, that's pretty much it with the deburring operation. Very simple, straightforward. You're just selecting the edges and the specific width, the specific step over here as well if you're doing multiple passes. You hit compute. Let's do a couple passes here too, actually. Let's do 3 passes to see how that looks. All right, I'll hit compute. And you can see if I zoom in here, the 3 passes total. I backplot it here. Starts in with a tangent move, tangent lead in and lead out there. And if I look at it from the side here, it's doing 1 pass here and then working its way down sort of diagonally so that it doesn't go straight down. It adds extra for the deburring there. And let's take a look at all of this in our simulation. So I turned off the planar toolpath. We've got the advanced rough, the second advanced rough to finish things up on the flatlands and inside the corners there of the 1/4-inch radius of the pockets of the corners of the pocket. And then we're getting into the morph between 2 curves and then the deburring operation. So here's our first roughing operation with the 3/4-inch tool. We're using a 1/2-inch tool to do that profile along the walls and machining all the flatlands there. Then we get to the morph between 2 curves. Again, with that profile, the flute length isn't long enough for the roughing. So I don't like seeing the red, so let's just turn that off, or let's fix that real quick here. Changing the 1/2-inch tool, let's just make the flute length a few inches longer here. Okay. It should be good. I should just have to finish it. If I'm changing anything on the tool page, other than the diameter, if I change the diameter, I have to compute the toolpath again. But if I'm just changing the small things like the flute length, I can just finish it out. So here's the second roughing. There's that profile pass around there, and then the morph between 2 curves here. With the stock, I can make it transparent. I can see it machining all the way around there. So yeah, it gives us a great surface finish, and then it does the deburring operation here. do a couple passes to do a deburring to make a chamfer along the inside corner there for the pocket. So once everything looks good, we can close out of simulation for this part file. Go to the top, we can hit post. It'll generate the G-code here on the right-hand side. And I can right-click anywhere in this window, go to Save As, and I can save it as a specific name, the file extension NC, and save it onto a flash drive, send it over to the controller. Real quick before we get to the next part file, I can also modify the G-code and send it over through an RS-232 cable if I wanted to, by right-clicking here in the window, going to NC Editor. It'll open up the G-code in a new window here. And you can see everything is color-coded here on the right-hand side. The comments here are in green. X, Y, Z moves are different colors, so we can easily find what we're looking for. I can go to the top and go to Tools, go to Start DNC Transfer, and I can set the port number that the cable is coming through the computer with, set the baud rate here, the parity, data bits, stop bits. All of those settings are found on the controller if you are sending it through a cable from the computer to the controller there. If you've got an older machine like that takes a cable like this, we also have drip feed options if it doesn't have enough memory for the G-code all at once. You can go to the next tab here, character delay and line delay. The software program will wait a certain number of milliseconds every time it sends a line of code for drip feeding there. So, you guys don't have any other questions with this part file and with the toolpath that we saw with the 3-axis premium so far, the morph between two curves, and the deburring here. We'll take a look at the next one. And I have this 3D model here, and it's sort of in an assembly. I've got a bunch of solid models, solids in here inside of the part file. I have soft draws, and I have the Kurt vise here, and the solid model itself. So then to begin my milling job with this one, again, I just go to the top, go to CAM, and start a new job. It'll be a milling job type again. Go to the specific machine I'm using. Go to Stock Wizard. Select my workpiece here. So I'm selecting the solid model and going to the next page. It'll create a piece of stock around the workpiece there that I defined. And I can make it cylindrical here is what I did. And I dropped it down a little bit more for the soft draws there as well. Excuse me. All right, and then our last page is our machine setup. And again, I can just define my G54 work offset by highlighting origin on the left-hand side and clicking on the top of the stock there in the center, and then clicking OK. Now I'm going to go back to the milling job that I had. I've got my stock right here. I've got my machine setup up at the top. Again, I right-click on Machine Setup 1. To save us some time here, I did do a 3-axis roughing operation in the 3-axis Pro again. So I went to Mill 3-axis. I selected my geometry here, and here's the toolpath of the roughing. One other thing I can show you guys as well is if we wanted to, instead of ramp or spiral into the stock, we can start from the outside of the stock and work our way in with the side of the tool, entering into the stock here. That's found under leads. And if I uncheck this box, center cutting tool, that will understand that the tool can start in instead of plunging. So under leads, instead of plunging down in or ramping down in, it will start, it won't use the center of the cutting tool to enter into the stock. It'll use the side of the tool as a side roughing option there. So that's where that is found under 3-axis Pro. Then we'll get into the 3-axis Premium toolpaths I did with this one. The first one I did was cuts along curve that I described earlier. I'm just selecting the surfaces that I'm machining and then selecting a lead curve that the toolpath is going to go perpendicular past. So I select cuts along curve on the first page here, set my work offset number, set my tool page, it's going to be 375 ball end mill, set my spindle RPM and cutting feed rate. Now with the geometry selection, it's just a little bit different than the morph between two curves. I select a lead curve, selected this top edge right here, and then my drive surfaces are just the top two surfaces right here that I'm focusing on. I did a trim and extend option here, or I'm extending it 100 thou past to go a little bit further past there to sort of set an extension for each step over. What else? Side extensions, adding an extra 50 thou to enter in there. And then tool axis control, again, 3-axis, gouge check, linking, direct linking, stepping over each time so it doesn't retract up to the clearance plane each time. Those are the only things I really changed. I set a step over of 15 thou here. You can also calculate it based on the cusp height. And this is my tool path. I can backplot it. I'm starting from the back end here and working my way across. So you can see that extension there of 100 thou a little bit further past to make sure that it's not going to miss anything, and that's going to machine everything possible there to extend it out a little bit past there. So that was the cuts along curve. Then we've got our morph between two curves again. I can show you the geometry of what I did going from that location down here. So after my tool page, I've got the first edge curves. You can see everything highlighted in red here. Just selected all of these edges around from where I left off. And then second edge curves, what I selected from right here, going all the way around here. And then my drive surfaces are all of the surfaces in between. Click OK. And that's what I'm machining there. I can set my cusp height based on the tool radius and based on the geometry remaining there. Now you can see the term in 3-axis premium is maximum step over. So that's something to remember there. Maximum step over. It's not a consistent step over the whole time, and we can see that here in this toolpath. The step over here is probably the maximum step over of, what is that, 50 thou? But when it gets down into the bottom radius here, you can see a much smaller step over to give us the same cusp height, the same surface finish, all the way around the side walls there. So we can do a larger step over up at the top. It's going to be machining a whole lot more with the ball end mill on the top radius there of the side walls. Then once it gets along the side walls, it's got to have a certain step over down with the ball end mill. And then once it gets down to the bottom to follow along these curved surfaces down at the bottom, it's got a smaller step over to follow that geometry. So it gives you that adaptive step over option there, like you would see in the advanced planer or something like that, but it follows along all of the contours to give us a great surface finish along the part here. I think that's about it. The other two are going to be morphed between two curves as well, I think. This one is morphed between two curves. We'll look at the geometry though. under the operation, I can see it here too. Drive surfaces, just these two surfaces right here. First upper edge curve were all of the edges on the top there, and then second lower edge curves down to here. Next, we did a Z-level finish from that level down. And then we did a morph between two curves, I believe, along the corner here with a ball end mill to follow along these edges here as well and just focus on that. The geometry selected were the drive surfaces of this fillet here. Upper edge curves were just the top edges there, and second edge curves were down at the bottom. And we'll take a look at the simulation and simulate all of our toolpath here. There's a whole lot of options under the operations under 3-axis Premium, so that's why I tend to collapse everything in here in the CAM tree so I don't have to scroll up and scroll down with all of that. So I'll go into the simulation. We can run through it and see if there's anything remaining here. Let's see, fixture, that's okay. So I'll run through it. Got our roughing operation first in 3-axis Pro, then our finish operation in 3-axis Premium, cuts a long curve on the top there. Again, it's going perpendicular to that lead curve in the middle of my solid. Then morph between two curves from there all the way down. And this is our last part file we're going to be looking at today. If you guys have any questions, please let me know in the comments section. Anything we've gone over today in the 3-axis Pro and mainly in the 3-axis Premium that we've focused on today with these milling operations. If you have any questions, comments, concerns, please let me know in there. And I want to thank you guys for viewing us live here today in the training session. We do this every other Wednesday. So this is September 25th. And if I look at my calendar here, we do a webinar every other Wednesday. So our next one is going to be October 9th, right there. It's right above me there. October 9th, right there. October 9th, same time, same channel, 1:00 p.m. Eastern Time. October 9th is going to be our next webinar. So if you have anything that specifically you want to go over in the next webinar, please let us know. We send out a survey to make sure we have these webinars focused on exactly what you want to look at in the software program. So if there's anything involved in the software program there you'd like to look at in a webinar, you can call or email us or fill out a survey, and it could be anywhere from 2-axis milling all the way up to 5-axis milling, lathe, mill turn, laser, plasma, water jet machining, wire EDM. We've gone through it all. And we do it every other Wednesday here in the webinars. Every other Wednesday, 1:00 p.m. Eastern Time through usually somewhere around 2 to 3 p.m. Eastern Time. And so, yeah, let us know what you'd like to see in the next one, which is going to be October 9th at 1:00 p.m. Eastern Time. And I want to thank you guys again for viewing the webinar today on Mill 3-axis Premium, and we will catch you in the next webinar. Thank you guys, and have a great day.